convert binary matrix to zero matrix. So we are given a binary matrix like this. We want to flip it first, and then we want to check what is the minimum step of flips to make this binary matrix to be zero matrix. It means all the elements to be zero. Yeah. So let's try to use this first example to understand why it works. So for the first example, we're gonna have 3 steps. So the first steps, we're gonna start flip. We're gonna start flipping from 1 0. So this is 1 0. We're gonna flip here. This is 1 0. So we're gonna flip it first and then go to the next state. Yeah, you should remember that for such kind of playing games, we should always have the current state and the next state. We're gonna use the state to solve the problem. If our final state is like 0 0 0 0, so it means we've already found an answer and we can return the steps. Yeah. So currently this is our start state. If we are starting from this one, so we're gonna try this one, 1 0. So if 1 0 flip, this gonna be 1, and here gonna be 1, and this one gonna be 0. And next we're gonna flip 0 1. 0 1, it's gonna be here. This gonna be 1, and this gonna be 0, and here this one gonna be 1. And next we're gonna flip 1 1. If we flip 1 1, so it's for neighbors to be 0 and itself to be 0. Yeah, because it's gonna flip itself and for neighbors. So it's gonna be 0 0 and 0 0. We reach the final state. Yeah, so this is a typical BFS problem, but we should also consider the state. So how should we know the current state on the next state? We can use binary representations to represent. So for example, we're gonna use like 0 0 0 1 for the current state, because like this is 0 0 0 1. We can use 4 binary numbers to represent the current state, and for each of the state we can use 4 binary numbers, because in total there are 4 elements. If there are 1 element, we can use 1 binary number. If there are 6 elements, we're gonna use 6 binary number. So this means each of the state is represented by the binary numbers. So if it is like 0 0 0 1, so the result, if we turn it into a digital number, it's gonna be 1. So 1 is the current state, and the final state is just 0, because for zeros it is still 0. How can we reach from the current state 1 to the final state 0? We just need to check the steps. So we can use BFS to check the steps. Yeah. Now the problem becomes easier. But how can we transform from one state to another? Yeah. So this means how can we calculate the sleep function? So currently this 0 0 0 1 is our current state. Yeah. This is our current state. And for this one, let me maybe use another color. Yeah. Yeah, this is something wrong. Yeah, let me just use this one. So this is my current state. It is 0 0 0 1. So the result is 0. Yeah, let me try to change the color. I don't know how to change the color. Maybe from here. Yeah. So I'm gonna choose white color. So I'm gonna choose blue color. Yeah. So yeah. So this is our current state. It is 0 0 0 1. We want to reach the final state. Yeah. So the binary representation is like 0 0 1, and it is 1 to 0. Yeah. Now we are going to calculate if we flip like this 0, the top left corner 0. How can we get the next state? Yeah. First of all, we're gonna put this position inside our direction array, and this is another direction, and this is another direction. We put all the directions in a directions array, and we're gonna check if it is inside the boundary. If it is inside the boundary, so we're gonna check the current number. If this current number is 0, we're gonna turn this number to 1. If this is also 0, we're gonna turn it to 1. If this is also 0, we're gonna turn it to 1. And 1, 1, 1, 1 is 15. So the 15 is the next state. If we are going to start from the 0, 0, yeah. So for another example, if we are going to start like 1, 0, 1, 0 is here. So we go to the next state. So what is this binary number? So it is 1, 0 and 1, 0. So this binary number is 10. So this is another state. Yeah, because of the different directions, we're gonna go to the different state. Yeah. This is just because we are flipping at the different positions, so we're gonna go to the different state. But for example, this 0 can go to the right direction to go to this 0. But can it go back? Yes, it can. It can go back. Only it can go back and forward. Only the state we find a state it is already inside the visited set. We cannot go back and forward. It will stop. Otherwise, it will be an infinite loop. Yeah. So this means while using the BFS, we're gonna use a visited set to check the state. We can never go back to a state that has already been visited. We have to go to the new state to explore, and until we find the answer. Yeah. The difficult part is about how to transfer the state from one state to another. So we're gonna use some bit masks, bit manipulation to calculate how can we go from the current state go to the next state, and we're gonna put the next state inside the queue until we find the answer. Yeah. Let me just start coding. So now we are going to prepare. Let me define start. So the start is the start state. So I'm gonna use gonna use some string operations to represent the binary operations, because string calculation is easier than bit mask. Yeah. So I'm gonna use for row in matrix and for columns in row. So I'm gonna use this start plus equal to the string of column. Yeah. So this means inside I will get a 0, 0, 0, 1, and I'm gonna turn it into a digital number. Yeah. Now I want to turn this number into this start. I'm gonna prepare this start variable should be equal to the integer of the string. The string would be the start, and it is a binary string. So I'm gonna use a 2, and I'm gonna turn this binary string into a digital number. Currently, this start would be 1 for the first example, because it is a 0, 0, 0, 1. This is our current state. Yeah, let me just print out the start, and we're gonna prepare for the next step. I just return a 0. Yeah, because we just wanted to check this start. Yeah. As you can see, the start is 1 because this is a 0, 0, 0, 1. So this is our current state. Yeah. Now we can put the current state inside the queue. So queue should equal to the queue, double added queue, and inside it should be a start. And here is the steps with 0 steps. And we're gonna also prepare a visited set. It would be a set. So inside of the set, it would be the current state. It is the start. Yeah, the start state. Now, I'm also going to prepare a directions array. So the directions array is just 4 directions. I will put the 4 directions inside. So it's gonna be 0, 1, 0, minus 1, and 1, 0, and minus 1, 0. Yeah, but itself should also be included. So I'm gonna put a 0, 0 inside, because I'm gonna flip the 4 directions and also including itself. So here I put a 0, 0 inside. Yeah. Now we are going to check the queue. So while the queue, we're gonna pop out. We're gonna prepare a state. This is our current state, and I'm gonna prepare a steps. should be equal to q dot pop left. We're gonna pop it out first. So we are going to check the state. If this state equal to 0, it means we've already found the answer. We just need to return the steps. Otherwise, we're gonna check the 4 directions. Yeah, because we're gonna check the 4 directions to flip it first. We're gonna flip it first to check the next state. Yeah. So for R in range R, for C in range capital C. Yeah. So here I will put R and C. I will put it here. Let me. Yeah. So here R would be equal to length of the mat, and C would be equal to the length of mat 0, and this one gonna be C. Yeah. Currently now I have R and C, so yeah, for it is in 4 directions. I have my next state. Yeah, let me prepare a next state. So the next state I will give it to my current state. Yeah, so this is just starting from, for example, we are starting just from 0, 0 position. We are starting from this position to check. Yeah, and now we are giving a next state equal to the current state to this state, but we are going to calculate the next state. What is the next state? We need to check the directions. So for dr dc in directions, we're gonna check the row and column. Yeah, it is just it can be flipped to the next row and next column. So this row and column can be this one, and this one. We are starting from the 0, 0 position. Yeah. So row and column should be R plus dr and C plus dc. Now we are going to check if it is inside the boundary. So if it is more than or equal to 0, less than R, and similarly for the C, the column should be more than and equal to 0, and it should be less than C. Yeah. Now if it is inside the boundary, we can get the next state. Yeah. Now we are going to calculate the next state. So the next state should equal next state should be equal to next state XOR. Yeah, here I'm gonna use some bit mask calculation because it's gonna be easier. So the next state would be equal to the next state XOR yeah, it would be XOR the positions of this row and column. We have to calculate this row and column. Yeah. So for example, if this row and column is here, it's top left. It is this 0 and 0. What is gonna happen? Yeah. So if there is no directions, only itself, because it includes 4 directions and itself. If we only calculate itself, so it is here. But for the binary calculation, so this 0 is at the highest bit. So we have to use a bit mask to shift this position to the 4th digit. Yeah, let me just explain it here. So currently we have 0, 0, 0, 1. Now we are going to shift this 0 to 1 because this is our position. We didn't go to 4 directions yet, but we're gonna calculate itself first. Yeah, we're gonna calculate this first number. This first number actually it is the 4th digit. So yeah, because this is the 1st, 2nd, 3rd, and 4th. So this is the 4th digit. We're gonna turn this 4th digit 0 to be 1. How can we check it? We're gonna just use XOR. If it is 0 and our number is 0, it's gonna be 0. So if it is 1, 0 XOR 1, it should be 1. Currently it is 0, so we're gonna use 1 to XOR with this 0 or 1. If it is 1, 1 XOR 1, it's gonna turn to 0. If it is a 0, we're gonna shift it to 1. So we can use the XOR operation to shift 0 to 1 or shift 1 to 0, to flip 0 to 1 or flip 1 to 0. Yeah. Now let's calculate in which positions we can shift. Yeah. So it's gonna be 1 left shift. So inside we are sure, so this position gonna be shifted 3. Yeah, so this 0 actually it should be shifted 3 positions to the left. So we can use R times C minus this row times C and minus column minus 1. Yeah, maybe I'm not familiar with this formula, but this is just a typical formula to calculate which position it is. So for example, let me use still 0, 0 to put it inside to check. This R times C is 4, and this is row and column both 0. So 4 minus 0 minus 0 minus 1, it is 3. Yeah, so it means it is 3 positions. So 1 shifted to 3 positions, it is exactly at the 4th position. So this is the formula. You need to understand why we're going to use this kind of a formula to calculate it. Yeah. So let me just use another example. Maybe, yeah, we're going to check this position, the last position. Actually, for our binary representation, it is this first position. Yeah. So we're going to put it inside. Currently, the R should be equal to 1, and the column would also equal to 1. Yeah. So this is 4 minus 1 times 2, it is 2, 2 minus 1, it is 1 minus 1, it is 0. So it means at this position, it is just at the position of 0. So 1 shifted to the left 0 positions, it is still 1. So 1 XOR 1, this one gonna become 0. So actually, this is just a flip operation. We can use this kind of operation to flip all the directions, including itself. Yeah. Now let's go to the next step. So currently, we've already calculated the next state. Yeah, but how should we use the next state? We just need to check if the next state not in the weighted set. So we're gonna put it inside. So the weighted set should add the next state, and Q should append the next state, and with a steps plus 1. Yeah, and finally we just need to return this kind of steps if we find it. If we didn't find it, we're gonna return a minus 1. Yeah. So this is the entire code. Now let me just run it to check. As you can see, it seems it works. Yeah. Now let me submit it to check if it can pass all the testing cases. As you can see, it's pretty fast and it passed all the testing cases. Yeah. Now let's still analyze a little bit about the time complexity. Because this is a bit mask problem, we're gonna check all the combinations of the state. So for the maximum mn equal to 3, so m times n should equal to 9. And for the binary number 2 to the power 9, 2 to the power of 9 is all the combinations of the state. So I think the time complexity is n times 2 to the power of 9. And this n is how many numbers? It is 9 times 2 to the power of 9. It is gonna still be a very small number. That is why it is so fast. Yeah. Now let's analyze the current state to the next state. So let's analyze a little bit about the code here. So this start, we are just calculate a start state. So for the binary number, this is gonna be 1. And then we're gonna put it inside the Q weighted set. We're gonna prepare directions and R and C, row and column. Now we are going to start the BFS. So we have a current state and we have steps. If we find it, we're gonna return steps. Otherwise, we're gonna check the next step. But how can we check the next step? For each of the next state, we're gonna start in from this current state. Yeah. So this is the current state, and then we're gonna flip from the 4 directions, including itself. So we get the next state. by this formula, we get the next state. So if this next state not in weighted set, so we're gonna put the next state inside the set, and also we're gonna put it inside the queue. Yeah. Now we are sure we have the next state. So we're gonna use the next state to pop it out of the queue and check again. So for here we have like 4 directions. We're gonna first put the next state, and then it will go to the 4 directions. Yeah, because here so we are starting from this R and C, and from this R and C we can go to the next state. Yeah, so maybe the next state, maybe next step we're gonna go from here. First of all, we are at 0, 0. We're gonna go to the 0 and 1, and then we're gonna start from 0 and 1 to search for the next state until we find a solution. Or maybe we are not starting from 0, 0. Maybe we are going to start from 1, 0. Yeah, it is also one possible answer, because we're gonna put all the possible results inside the queue. Currently, it is the steps is 0. If we put it all inside, the steps would be increased by 1 until we find a final solution. So for example, yeah, if we flip at this position, our steps would increase 1. But we can flip at any positions. Yeah, so this is how many positions. There are 9 positions. And how many different states? It is 2 to the power of 9 states. So this is for the time complexity and also for the space complexity. Thank you for watching. See you next time.